Hi, this video is an instructional video to speak and talk about how to assemble the All Nation line Flex-i-Coil truck. This was an EMD truck that was common on many switcher engines. Step 1, you'll notice that we have the side frames laid out here on the board, and these have come directly off the printer plate. They're 3D printed in ABS, and the first step is to remove the build support material on these particular side frames. And by that, you simply peel this support material back off of the underside of the side frame, and you'll want to clean this up as best you can and just simply pull this material off. It's a little bit difficult, but once you get it started, it comes off just fine. The end result that you want to get to is the underside of the side frame that will look just like this. Now, in so doing, what makes this a little bit easier is if you use an X-Acto blade to kind of scratch off some of the material. It'll loosen right up. You can get in the corners. You can slide it down. And what you don't want to do is to be using this and cutting towards yourself so you won't accidentally cut yourself. But you want to smooth this out as best you can. Most of this material will peel off relatively easy. You can take and go gentle with it. You don't have to force it. And we'll do both sides, and you'll notice that when this opens up, this side here is a little more robust in terms of the material. It didn't come off by hand, so you just get under it like so and start peeling it back. You'll notice that as you clean it, there will be holes for the journals, and I generally stick the blade in like that, give it a twist, and later on we'll show how to clean these holes up more thoroughly. The next step, of course, is to get this inner surface nice and smooth, and the way we will do that is with our Dremel. Okay, step 2, we're going to smooth the inside surfaces after we've removed the build support material on this part, and we'll do this for both side frames. Now, I've set up the Dremel tool to be full speed, but I have a control on my foot pedal control for controlling the speed with my foot, so it's a hands-free type thing. Now, I also have went ahead and put in a router type bit so that I can smooth the surfaces over, and we'll do a quick demo here to show how easy this is. Now, I would suggest wearing earplugs so that the noise of the Dremel doesn't harm your hearing if you're using Dremels a lot, and also a mask to prevent you from breathing in any type of particulate while you're doing this operation. Okay, now step 3, since these side frames have been created with close tolerances, what you want to do is check with the wheel sets that come with this kit to see just how close these wheels come to the actual brake shoes. And they do rub, they fit in, but what I typically do if there is rubbing, because sometimes there's a slight amount of shrinkage after printing, see that fits right in just nice. That's probably on this piece a little too tight for comfort, so I usually take and use a Dremel cutting disc 409. I've changed the router bit out and put in this disc, And this seems to be the right radius or circumference. So just go ahead and clean these face of the brake shoe a little bit, just like this, just enough to give it clearance, and it'll give it a realistic look once it's all together, and it should roll freely. So you want to do this to each brake shoe, just the face of it, and keep that circumference, and keep testing with your wheels to make sure you get the adequate clearance that you need, and it'll turn nice and easy. Okay, we're going to move on from step 3 to step 4. Step 3, we were cleaning out the surface here, and we also took a little material off of our brake shoes on the inside, but we don't want to do the total face of the brake shoe. We want to leave that detail on there on both sides. So in this step, what we're going to do is we're going to clean out the journal hole to accommodate the bearings that go in the journal. And to do this, I've installed on the little drill press here a number 3 bit, and we want the journal to be just big enough or wide enough to accommodate that bearing so that it floats a little bit. I decided I didn't like a really tight fit, so we're going to drill a couple of these by hand. You can set it up so that you don't risk drilling all the way through your part, but I've done enough of these to know that just about how far I want to go. Now this drill press is noisy as heck, and so we'll just do 2 of them here real quick. You want them just deep enough so that the bearings are flush. A little deeper is okay, because potentially your end of your axle is going to go all the way through the ball bearing on these, so that is not an issue. Now the other thing I like to do on the front of these is open this hole here and here on the face of the bearing, and I like to be able to do that to lubricate it if necessary. Next, we switched from a number 52 bit to a clearance bit for an 090 screw, which is a number 55. And what we want to do next is we want to clear out a clearance hole here and here for our hex machine screws when we mount the bolster part on the back side of the side frame. So we'll do a quick drill out here. So the hole is already pretty much open. It's just a matter of clearing any possible build threads or material that developed during printing. So now the hex screw will slide right through that, so we can then attach the bolster part to the back side of this side frame. So the next drilling operation we're going to leave the number 55 bit in the drill press, and we're going to clear out the holes for where we're going to mount the slack adjusters. Now the slack adjusters, I'm going to show you a oversized version of the slack adjuster will be installed on these side frames. Now this is the oversized, just so you can get a better picture of what the part looks like, but it's much smaller at scale. And so we'll use optical screws here and here to mount to these mount points here and here, here and here on the trucks. So let's go ahead and drill these through. Just clear them. And there's only one more drilling operation that we need to perform at this point in time, which we'll show next. So as I mentioned before, we drill these two clearance holes for the hex screws to go through so we can mount our bolster part here on the back side of the side frame. This bolster component has a stud on it and two little holes here, which we're going to use a number 60 drill, which I have installed here, so we can tap these holes for the machine screw. Once we put these screws through, you can decide to glue this or just use the screws to make this a solid piece. You'll also note that there's a hole in the stud. That hole is drilled for a 256 screw, which we will tap with a 256 thread. We'll tap these smaller holes with the 090 tap. So we'll get a nice good bite on that. So we're going to go ahead right now. Next, we'll change out the drill for the 256. And for a 256, we're going to need a number 50 drill just to clear that hole. We'll stick that in here in just a second. So we're going to put that drill bit in there, crank it up. And the holes will put across the balloon, So really what we're going to do, and I'm not going to spend a lot of time showing how to tap these because it's pretty straightforward. We'll use a 256 tap to tap those stud holes, because that stud hole is going to have a set screw, a 1/2-inch set screw to go through here to hold the bolster. We'll also use the 090 tap to do these holes. So after doing all that drilling, the next step is to take your bolster, and the way we print these is they're flat on the build plate with a lot of support material. So you have to remove all this support material. It helps to have sort of a small pair of long nose tires to grab on some of this and just pull it off. And when you're all said and done, it's going to look like this. Now, these holes here, you might need to take a fine file and smooth those out a little bit. Because when this part is mounted on the side frame, you're going to have this part here, because you want this bolster to be able to rotate a little bit and have some flexibility. So when this goes all the way through, you'll use your set screw to connect the bolster to these studs. So that's probably the last step in terms of having the clean parts. The side frames, this bolster is all done in ABS plastic. This is PETG. The brake adjusters are ABS, and the only other type of plastic material we use for the end bars is the TPU, because they're very flexible and they're going to allow the truck to have some flexibility, as well as it being able to go down the track and not be totally stiff, which would be okay for a static model, but for an operational model, you need to have some flexibility, because the side frames are not fully sprung where the journals are going up and down. They're fixed or printed into the main side frame, but they will work just as well so long as you have some other flexibility in the truck. So what I went ahead and did off camera was to tap the smaller 090 holes and the 256 screw holes, and then I also took a flat fine file just to make sure there's no burrs or flashing. So when I go to fit this onto the bolster, it's a nice tight fit, but still loose enough. And we will now proceed to mount this to the side frame. And it's easier to do by taking this off and starting our screws in these holes first. So I put my 090 hex screw into my little socket wrench here, which is a double O, and I'm going to show you that this screw slides into the clearance hole, and then we're going to get this started just like so, and start turning. And then we're going to go ahead and just take and do the other screw, so make sure our hole alignments are good, and we didn't lose anything due to shrinkage since it was printed. And I'm going to go ahead and get this other one started, and we're going to run those screws all the way tight. Now, if you wanted to, you could put some CA glue in there if you wanted to make this a solid piece. Normally, I don't bother. I'd prefer to be able to just take this off in the future if I need to service it. Now, note that when we put these on, you want the holes so that there's these holes aren't centered on the center line for this stud, and if you turn this upside down, this part will be way too low. So you want to make sure that you have it flush right here before you tighten these up. You can get it upside down, and then we'll run those tight. Yeah, they come through a little bit. The screws are a little bit long, but I prefer that. And then, so we got a good tight bond there with the screws, and then we're all set. We can go ahead and put our bolster on this one. You'll see that there's enough play here so that the side frames can navigate down the rails and be able to shift. So we'll put this stud on the other side frame, and we'll be pretty much ready to put our ball bearings and our wheel sets into this and bring this together. Now, having said all that, my suggestion is to, at this point, put the slack adjusters on, because it's a lot easier to do it while the side frames are free rather than with your wheel sets and everything in there. So that's what we'll do next. Continuing on, I paused momentarily to put the slack adjusters onto the side frames, on both side frames, and now that we have this part drilled and tapped, wanted to show how we connect to that stud using the 256 half-inch set screw here with a little Allen wrench, and we just turn that in, and that's going to secure the bolster to the side frames. Now, we did use the 090 hex nuts with the socket wrench as I mentioned previously, and we will do the same thing on the other side frame so we can begin to assemble the wheel sets into the frames. I also checked for any flash and make sure that this will pivot in here nicely once we get it mounted. I should note also that if this set screw goes in and it feels sticky or tight, just put a little tiny drop of kerosene on the thread or in the hole, and you can hear as I twist it in, it's making quite a little noise. But if that's lubricated a little bit, it should go in very nicely and keep this interface nice and snug. So as I said, I used a little bit of kerosene because it's very thin and it will lubricate just enough for this 256 set screw to get threaded through the stud and hold the bolster on. You will note that you'll want to make sure that this rotates and it's not too tight, and if so, use a rat tail file just to burnish this in here so that you get good rotation on it. And when you again mount this on the side frame, these holes and this edge have to be flush with the bottom of the side frame. So now we're ready to go ahead and put some wheel sets in this. Now, I haven't put in the set screw on this side yet until we get the wheel sets in, but the reason for going with a set screw like this is to afford an opportunity in case we want to bring some electrical pickup on the wheels. So this thread may come in handy later with a 256 nut on it. So before setting the wheels and the bearings in place, I usually go ahead and run this set screw through the stud just to make sure it's got a good grip, it turns freely, it's not going to fight me going in, because it's usually a little bit tricky to get these wheel sets in without losing your bearings. Since we're not gluing bearings into the journals, I want them to float free. So usually the way I go about this is I set the bearings in the journals on one side of the side frames, then I check my wheel sets and look for the insulated side, and what I want to do is set these wheels into the bearings. So I've got my truck set up with my bearings on the side frame with the wheel sets insulated on this side and this side, non-insulated here and here, and I set the bearings on top of the axles there. And what I'm going to do is I'm going to hopefully just set this on top and then use my set screw to firm this in tight. So there you have it. Now I'm going to put the set screw in there just to firm that up, and the wheels should turn nicely. You can check that out before you put the set screw in. If it feels like something's rubbing, then it's a good chance that a little more material needs to come off the face of the brake shoe, but you want to keep that as close as possible so it looks realistic. Now as I turn that in, you might be able to hear it squeaking a little bit or feeling like it's tight, but it's actually pretty loose. It's not super loose, but it just feels just right, even though it's creaking or squeaking a little bit as it's going in, and that's fine. We don't want that set screw to come out of there while you're running your truck, and it's just easier to put it in this direction instead of horizontal. That was my preference. I mean, we could have done it the other way, and I just want to run this in a little bit more so you can kind of see, and it's coming through the other side, of course, and that's what keeps that nice and tight and gives us the type of truck that we want. Now the only thing left to do on this, and you can see we want this bolster to be able to rock a little bit in there, so that's another thing we want to check and make sure it is loose enough to rotate a little bit. So the last thing we have to do is we want to put on these end bars And I just usually put a little tab of CA on these on each end. And of course, these end bars need to be cleaned up a little bit. There's a little fuzz on them from printing. And what we'll do is put those on, and then we'll mount the air brakes on here. And that should just about do it. And here is the finished kit. I would say at the discretion of the modeler, you could add a little more detail if you wanted more piping, that sort of thing. But for my purposes, I'm happy with the way this turned out, and I want to see how it's going to look on my switcher engine. And let me just take and turn this a little bit so you can get an idea of what it looks like from a side view. The truck will also accommodate a transmission because I've left enough space in here for drive shafts. So that's the other consideration, as well as the option to wire this for electrical pickup on 2-rail low scale.